Welcome, everyone, to today's Explainer. I am absolutely thrilled to be guiding you through this masterclass. When we study software engineering, it is so easy to just obsess over the code, right? The algorithms, the system architecture. But today, we are going to focus on something entirely different, yet absolutely foundational. We are talking about human psychology. Because at the end of the day, large software systems, they're built by people. Understanding how human beings work together, how they communicate and organize themselves, is just as critical to the success of a project as the programming language you choose. So, let's dive right into this. So, here's our roadmap for today's explainer. We're going to start with a quick intro to software teams, move into building cohesive groups, and then explore team organization and roles. After that, we'll look at group communications, do a rapid-fire master recap of Chapter 22, and wrap the whole thing up with a final summary to get you fully prepped for your exams. All right, let's get started with Section 1, Introduction to Software Teams. So why do we actually care about how humans work together to build software? Well, it's because most professional software isn't built by a single person typing away in a basement. It's built by groups. And since it's practically impossible for a massive group to collaborate effectively on one single problem, we have to break these large systems down. Now, here is the golden rule. The absolute ideal size for a software engineering group is 4 to 6 members. And you'll definitely want to memorize this next bit. A team should absolutely never have more than 12 members. Why? Because keeping teams small drastically minimizes communication overhead. It means everyone knows everyone else, and the whole group can literally sit around a single table to discuss the program they're developing. Moving right along, let's get into Section 2, building a cohesive group. Now, just throwing 4 to 6 brilliant people into a room doesn't automatically guarantee success, right? We need them to bond. So let's define exactly what a cohesive group actually is. A cohesive group is a team that thinks of itself as a strong single unit. In this kind of environment, members believe that the group's overall success is fundamentally more important than their own individual egos. The members become fiercely loyal. They deeply identify with the group's goals, and most importantly, they protect the group from outside interference. This makes the team incredibly robust when those unexpected problems inevitably pop up. And this robustness perfectly illustrates why project managers strive so hard for cohesion. There are 4 distinct benefits you need to know. First off, cohesive groups establish their own quality standards by consensus, which means they are much more likely to actually respect and follow them. Second, individuals learn from and support each other. That fear of asking a stupid question totally disappears. Third, knowledge is shared continuously. So if a key developer leaves the company, the project doesn't just stall out because others can easily step in and take over. And finally, they collectively take ownership of the code. This encourages constant refactoring and continual improvement, regardless of who originally wrote those specific lines of code. It's collective success. So the million-dollar question is, how does a manager actually build this cohesion? Well, first, you establish a group identity, maybe something as simple as giving the team a name. Second, you organize inclusive social events, like team lunches or away days where everyone can relax and learn together in a low-pressure environment. And third, and this is perhaps the most crucial one, you must share information freely. Treating your group members as trustworthy and actively avoiding a climate of secrecy prevents mistrust and makes absolutely everyone feel valued. Okay, let's transition into Section 3, team organization and roles. Now that we understand how groups bond, how are they actually structured out there in the real world? Because a group of people without any structure is going to really struggle to deliver a complex program. There are 2 main ways to organize a team. First up, we have informal groups. Think of Agile teams, where decisions are made by consensus. Now, this is fantastic for experienced, highly competent engineers. But there's a common misconception that Agile is always the best choice. In reality, for a team of absolute novices who really need experienced direction, informal structures can be dangerous and easily lead to project failure. On the flip side, we have hierarchical groups. These are structured much like the military, relying on strict top-down instructions. While this allows for very rapid decision-making when dealing with well-understood problems, it often fails in complex software engineering. Why? Because rigid top-down commands severely stifle the complex, multi-level technical communication that you absolutely need to build software. And that brings us to a very specific danger in team organization, what we call the super programmer problem.
The textbook notes that the absolute best programmers can be up to 25 times more productive than the worst. So naturally, it's really tempting to just build your whole team around one of these brilliant individuals. But let me warn you, this poses massive risks. It highly demotivates the rest of the team, who end up feeling resentful and sidelined. Furthermore, if that super programmer decides to leave the company, well, you have just created a massive single point of failure that can completely destroy your delivery schedule.
To put this into perspective, let's look at a case study from the textbook featuring a manager named Alice. To avoid competing egos and that super programmer trap, Alice recruited a team based on complementary personalities, mapping them directly to their primary motivations. She assessed members as task-oriented, meaning they're motivated by the technical work itself, self-oriented, meaning they're driven by personal success and getting the job done, and interaction-oriented, meaning they're motivated by their colleagues and really facilitate communication. To be successful, a team absolutely requires a balanced mix of all three of these types to function smoothly. Right, moving on to Section 4, group communications. We've talked a lot about how people are motivated, but how do they practically exchange information? Let's look at the actual mathematics behind human interaction. Here is a vital formula you definitely need to memorize for the exam. N multiplied by n minus 1. This calculates the total number of one-way communication links in a team, where n stands for the group size. So if you have a team of just 8 people, you plug 8 into the formula. 8 times 7 equals 56. That means there are 56 distinct communication pathways in a team of just 8 people. This perfectly illustrates the exponential growth of complexity, and it proves mathematically exactly why we cap our teams at a maximum of 12 members. Beyond just team size, several other factors dictate whether communication is going to be successful. The physical work environment is a massive one. You really need a good mix of open plan spaces for collaboration alongside private areas for deep, uninterrupted concentration. And of course, as teams become increasingly distributed, with more people working from home, digital communication channels become the absolute lifeblood of the project. We're talking wikis for central documentation, instant messaging for quick problem solving, and blogs for threaded discussions. These are absolute critical to keeping the team connected without relying on endless, inefficient email chains. Okay, let's shift gears now for Section 5, Chapter 22, Master Recap. All right, we've thoroughly covered the teamwork section, so let's do a rapid-fire master recap of the entire project management chapter to get you fully prepared for those exams. Question 1. Why is software project management so wildly different from managing the construction of, say, a bridge or a skyscraper? The answer? Because software is completely intangible. You can't see it, you can't touch it. A manager can't just walk onto a physical site and see that the steel framework is half finished. They have to rely completely on secondary evidence, which makes tracking progress and managing the project uniquely difficult. Next up, you must memorize the 4 distinct steps of the risk management cycle. Step 1, identify the risks to the project, the product, or the business. Step 2, analyze their probability and their potential impact. Step 3, plan your strategies to deal with them. And finally, Step 4, monitor those risks continuously throughout the entire project lifecycle. Now, when you're in the planning stage of that cycle, there are 3 specific risk planning strategies you have to know. Avoidance strategies mean changing the project plan to ensure the risk literally cannot happen. Minimization strategies, and please note the spelling there with an S, mean taking practical steps to reduce the impact if the risk does actually occur. And lastly, contingency plans are your emergency backup actions, designed so you can recover immediately after a risk becomes a reality. We also touched on Maslow's hierarchy of needs earlier when we were looking at Alice's team. Remember how this maps directly to the 3 workplace personality types? Task-oriented individuals are driven by the technical challenge itself. Self-oriented people are driven by personal success, esteem, and just getting the job done. And interaction-oriented individuals are driven by social needs and actively working with their colleagues. Recognizing these specific behaviors is absolutely key to managing people effectively. And that brings us to Section 6, Final Summary and Exam Prep. Let's distill everything we've covered today into the ultimate takeaways you need to carry forward into your tests and, frankly, into your professional careers. Here are the absolute non-negotiable facts. First, the ideal software team size is 4 to 6 people, which drastically reduces communication pathways. Second, cohesive groups are vital because they naturally self-regulate their own quality and share knowledge. Third, while hierarchical structures work great in the military, they heavily stifle the complex technical communication needed for software engineering.
And finally, they wear the super programmer. Building your entire team around one person creates a massive single point of failure that severely risks your entire schedule. I really want to congratulate all of you on completing this project management module. You've just learned that software engineering is honestly as much about managing human psychology and behavior as it is about writing algorithms. So, I want to leave you with this final provocative thought as we prepare for our next topic. How will you translate this new understanding of human psychology into writing better, more reliable code? Really think about that. Thank you so much for joining me in this explainer, and I'll see you next time.